Okay, good morning, everyone. My name is Angel Lopez, and I think it's fine like this. Yeah. I'm working at ECMWF. We are implementing one of the Copernicus services. We have been entrusted by the European Commission. We are currently implementing two of them, the atmospheric monitoring and the climate change. This is a global view of the Copernicus program for those which are not familiar. There are the space components, the in situ components, and there is the services. And what we have implemented in order to support the implementation of the climate change service is what we call the Climate Data Store, which provide a data portal in order to have access in the same place to all the different climate data across different organizations. So it's considered as a distributed system. We offer completely different set of data set, from observation to reanalysis to climate projection to seasonal forecast. On top of that, in addition, we have what we call is a toolbox, which allow us to retrieve the data and to process this data and create outputs that can be visual ones or can be another additional files. So this is the global picture of what we are covering, all the different components that we are putting in place. So at the very beginning, we have this complete set of data sets, which are completely different one each other in terms of format, size, volumes, and even scope, apart from all being related with the climate. In order to have access to all these data sets, one of the technical components we have put in place is the adapters, which are able to understand the request coming from our portal to translate it into a request, which is we can send to the data provider in order to retrieve the data from the different data sources. Then we have another component on top of that, which is the broker, which is the one which is in charge of managing all the requests, where we manage all the quality of service in order to make priorities, to manage different users, and to manage the access to the data. We have a common data model on top, which is this allows us to harmonize all the different data sets in order to be able to combine them on the system to produce outputs. And then we implement these tools, workflows, which is a set of concatenated tools and data requests. And on top of that, we are able to create final application more oriented to the final users. All this infrastructure has been deployed, is running in a cloud that we have in-house in order to offer high computation on top of all this data. We integrate many different technological components for each of the different elements in the infrastructure. And we are already open. Last year we were developing the system. This year it's already open, so you can visit the site. You can log in, you can create your own account. It's open for everyone. And then you can start retrieving data. What you will find, I will try to jump later as I will try to jump directly into the system, but this is what you will find inside. This is a catalog of data sets. This catalog is put in GeoNetwork in order to offer the catalog service, so to harvest all this catalog in other catalogs. Per each of the product, you will discover a short description explaining what is the data set about, what is the scope. We try to enmascarate all the metadata, but at the end is what is this about, is to explain what is the data about. And there is this form, which is the interesting part, is we are allowed in the same place to create requests to different data sets, to completely different data sets. So the user always use the same interface. So what we do is we configure each of these widgets depending on the data set, and behind we choose the adapter that needs to connect and send the request to the different providers. We also have an API, so all these functionalities can be used through an API. You can retrieve and you can send all the requests through an API. Then you send your request. The request goes through all the different components that I have been presented before, and then you are able to download the data. At the end, what is happening behind the scenes is you choose the adapter. If there is no adapter for this data set, we need to create one when we configure a new data set into the system. And the user goes into the system, discovers the data product in which he is interested. He fills the form, he makes the request, and then he sends the request to the final provider. And then we retrieve this data and present it to the user. So this is basically what is happening behind. This is for requests, so it's just to retrieve raw data. But if you want to do something more advanced on top of this data, we offer the toolbox with this common data model I was explaining before. So at the end is to create a multidimensional array, which allow us to combine all the different data sets. So by creating these workflows, our workflows used to be composed of retrieve, so we bring some data, we convert this data into the common data model. We apply the tools that we have defined in the workflow, and then we provide an output to the user that can be a file or can be a final application. This is how the toolbox looks like. So at the end is a work environment for the user. You can create your own program, all is based on Python. So on one hand, on top, you declare all your libraries, then you create your request, and then you provide the output. So basically, it's 3 different blocks. The idea later is with all these applications, they will go through a quality control, and if we consider that the application is valid for the public, we will publish also the application through the catalog. The same, at the end what we do is the user came, he can send requests to different data sets, bring information from different data sources. This information, these different files came into the compute area where the common data model is and all the tools. And then we come back to the user with the final output. As I was saying, it's not a presentation anymore. It's an operational system, which is already open. It was open in July, the 14th of June, sorry. And we have already 122 countries, representation from 122 countries, more than 2,000 registered users. Of those, more than 1,000 are already retrieving data, so these people that came into the system to retrieve some data. And we have an average of 20 new users per day that are registered into the system. And since the opening, we have processed more than 400,000 requests, and we have delivered more than 270 terabytes of data. The distribution for the time being of the users is most of them came from the academia, but we also have a big representation of public institutions. and also the private organizations. So we have a very diverse set of users using the system right now. Just to show you that the system is there. This is how the system looks like. As I told you, you can go there. Just one thing, if you came and you start using it and you want to provide us or come back to us with some comment, you have on the top, you have a link to provide us with your feedback. Even if you have some issue using the system, you can come to us and we will come back to you with an answer. We have a help desk behind that will be supporting all the users. So this is the catalog. You can create your search. You can filter for what is your then you can see how the data products look like. You create your request through these forms. You can copy your request in order to be used in the API, in order to facilitate the integration of the different requests that you create. You can bring the request directly into your API. And then you can submit the request. And then we have a cache system, so the reason it's so fast, not always it's so fast, but we have a cache behind. And then once you are here, you can download your data. And this is the toolbox, which we provide with some examples that you can use, you can import. And you can work with it. So this is the climate data store. If you are interested in this data, just please register, and start using it. Thank you.
Maybe we have time for one, maximum 2 questions.
Thanks a lot for really impressive work done so far. I would have 2 fast questions as we are really planning to use this tool for various reasons. First of all, to what I understood, we are able to query the content of the system also through the machine-readable catalog service endpoint. And the second question, when you presented this toolbox, does this toolbox also allows the developers to actually develop some applications which can be deployed outside of your environment? Thank you.
For the time being, for the second question, the developer has to create the application in here, and the application has to run in here. If there is a demand of people to export these tools, or this application in order to run in other place, we will see. But for the time being, this is the work environment, and all the components that you are developing to create your application are embedded in the system. You need to be in here, and the application will run in the facilities that we offer.
Yes, good morning, everybody. Yes, my name is Henrik Sten Andersen. Yes, I work at the European Environment Agency. And I'm here because we are also supposed to be responsible for the cross-cutting coordination of the Copernicus in situ component. You saw it before. We have services, we have space, and we have in situ. And so whenever there is a need for cross-cutting coordination activities, we are supposed to step in. And I'm going to explain you a little bit about one of them, where we focus on Inspire. We made a very simple test. I'm going to explain to you how we did it and the result. And at the end, I would need your help. So let's see how it goes. In fact, it is a very simple test. And why? Because when we look at Copernicus, many of the services are supposed to produce pan-European products. In order to produce and validate these products, you would need in situ data. And often you would need what we call pan-European coverage. We would like harmonized data, we would like up-to-date data, and openly available data. So of course it's obvious that we need to look to Inspire to find these data. So it's clear, and it's working every day, in fact, that Copernicus is actually benefiting from the member states' implementation of Inspire. That's clear. We would like to take it a step further and say, in many cases, it's not about individual data sets from individual member states. It's about creating a pan-European coverage based on these individual contributions. So we said, okay, let's try. Annex 1 should be ready. Let's take a simple data set like administrative units, and let's see how far we can get. So this is actually what we did in all its simplicity. And actually the conclusion right now, as we can say, is that it is an up-to-date data set. It's based on authoritative data, and it can be created automatically rather quickly, actually. Of course, there are many problems. I'm going to explain some of them to you right now. But there's also one important issue that we need to look at, because we need to expand this idea to other more difficult data sets. And I will explain to you how we're going to do that. So where are the problems? Because there are problems. I started with the conclusion, yes, it is possible. It is actually possible to take Inspire-compliant data sets from individual member states, put them together into a harmonized data set. It is possible. It will require some work, but it's possible. Of course, you run into problems. For example, at the time when we did the test this spring, we could only access data from 20 countries. How did we do that? We had a look at the Inspire Geo portals. We have a look at national catalogs. We had a look in CORDA, actually, what we call the Copernicus Reference Data Access Portal. And in some cases, we actually had to go to the member state to find the data. So, it is somewhat difficult to find the data also right now, even though we are looking at Annex 1, a simple data set like administrative units. So, okay, we had to do some work to find the data. Then we had to do some work concerning the formats. Some of the data were simply presented as shapefiles, some of them GML, some of them we had to extract from a WFS service. But okay, we managed that. Then also, in some cases, for some countries, we are talking about a quite large data set. And it can be problematic to download a large data set if you work with GML files and WFS. And then also, in some cases, the organization of the files. In most cases, of course, we are talking about a single file. But for some countries, it will be split up in regions, for example, so you can end up with, let's say, 16 files instead of just one. So, all these things, you need to learn, you need to work with it before you can actually make some useful out of these data. Also, we have to realize, of course, that, and you know that, whatever the level of harmonization and compliance, data sets will be different. When you talk about detail, you talk about accuracy, data sets will be different. So we need to find a way to merge these data sets, even though they are different. Some data sets we found were simply incomplete. They were missing data. We had to go back to the data provider and say, okay, can you correct this? And it was corrected. But we needed the dialogue with the data provider. Also, we found inconsistencies, of course, as you would expect, in the border regions. We found that in some cases, attributes were missing. In some cases, actually also, which is probably also important, is that when we talk about optional attributes, In some cases, it would actually be very, very beneficial to include them because it would be more easy to work with the data. But I mean, that's something we need to look at. In some cases, we also found that the coordinate system was not correctly defined. And all these minor issues, you may say, we need to correct either ourselves or we need to go back to the data provider and ask them to do something about it. Of course, the Inspire validator helps us a lot. It helps us to understand the data set. It's also clear that data set analyzed have different levels of harmonization. Of course, it will affect the way we can actually work with these data. But also, it became clear that working with harmonized data sets is actually very feasible once we have overcome these initial problems. So the thing is that we need to realize, and it's maybe completely evident to you, we need to realize that the idea of pressing a button and then getting a harmonized data set is really fantasy. You need to work with the data, you need to do something, but you learn while doing that, and the next time it's actually going to be much easier. Handling fees in some cases actually prevented us as a first step to use these data. So, I mean, of course, these data are free, but member states are in some cases allowed to have handling fees. And by introducing something like that, and when considering that, I mean, the basic principle in Copernicus is not to pay for the data, then, yeah, I mean, it was simply a barrier that we needed to overcome. But I mean, we managed to do that in one example at least. Okay, so what are we going to do now? Because, I mean, we will not stop here. Evidently, of course, we will start updating the data set that we have produced already in spring last year. And I should also say now, when I say we, in fact, it's one of our contractors, Geogram from Spain, part of the Corda team, who actually did this work on our behalf. But they will actually try to update this data set. Hopefully, more data have become available from member states. Hopefully, more data has been corrected. And we will update the data set. We will also, because we have been talking to the Copernicus Services, and in particular the Copernicus Emergency Management Service, and they said, okay, could you try to do something about buildings, footprints? Could you do something about hydrography? And that's actually what we are trying to do now. So we will expand this idea. I mean, it's a piece of hard work, in fact. It's not very difficult, but you need to do it. So we would like to expand, try to do this with more difficult data sets, collect a lot of information, and then let's see how it goes. The idea is, so when we have created this data set, downloaded the data, combined them into one pan-European data set, these data will be available through what we call the Copernicus Reference Data Access Portal. But in principle, I mean, we could, of course, make them freely available to everybody. So, and now I need your help. So what can we actually do to improve the situation? I mean, we need to have all the data in there somewhere. I mean, of course, we need to be able to find them. But the data should be available. When we returned to some of the member states and said, okay, we cannot find your data, they said, okay, it's on its way, within a few months it will be available. We will check now and see if we can actually add more data to the data set I showed you to begin with. In some cases they said, okay, we are simply not ready, it will take some time. Okay, I mean, but we need to have more data available. And also, of course, this exchange of information, this dialogue is so important because we gain a lot of experience during this work. We see, okay, the reference system may not be correctly defined. There may be some missing attributes. There may be some missing data. And of course, we need to go back to the data provider and say, okay, can you please do something about it? So we need this dialogue. But how can we do this in the most efficient way? And of course also, and I don't know, to be honest, if there's already some kind of a checklist or a paper with guidance to the member states. Okay, before you publish a data set, please go through these steps to ensure that the quality is fine. But I mean, my question is to you, what can we actually do to improve the situation? It's a very, very simple test. We would like to combine INSPIRE-compliant data sets from member states into one pan-European coverage. I mean, that's part of the idea, isn't it? So how can we ensure that more data will be available in the future? How can we ensure how can we actually facilitate an efficient dialogue with member states? And how can we also, in some cases, ensure that the quality will be improved? Thank you.
Thank you, Henry, for your presentation. My name is Antonio Rosarena from the National Mapping Agency. Well, that you express here is part of the problem, because it's a technical problem that you are presented before, because many member states, they don't know nothing about the technical requirement for the Copernicus. They produce only in order the accessibility of the existing data for the INSPIRE. But the question is, last week in Brussels, you have also in the same meeting than myself, you published that immediately you are published an open tender for the industry in order to produce for all Europe the hydrographic network, digital elevation model, and transportation network. Well, in this case, it's very difficult because in the future there will be two different data sets. One for the member states, produced inside of the INSPIRE, and the other one produced for you, for the European Environmental Agency, for the industry. Do you think that it is possible in the future to combine these two philosophies? It's very difficult because many member states spend a lot of money in order to achieve this information today. And finally, the European Environmental Agency decided not to use nothing of the INSPIRE data set for the member states. Which is the solution? My solution, my support, I think it's better at least those countries that it is possible to present and to prepare this information, please open the door for the member state that it is possible to facilitate this information. Thank you.
First of all, I think that the part of the idea behind INSPIRE is that, in principle at least, we should be able to combine these data sets because they share a model, they share an idea. And that's what we tried, of course. I mean, yes, if you look at Copernicus and the services, they say, okay, we would like these data to be downloadable, we would like harmonized data, we would like pan-European coverage, and that's what we are trying to do with member states' data. And that's also what we are trying to do through this Copernicus Reference Data Access Portal, where we make member states' data available to the services. So we try actually to make these data useful for the services. I agree that why punish the good guys? Who actually makes the data available? I mean, we should not do that. And that's exactly what we are trying to do now. Because we are not going to stop, even if data from only 20 member states will be available. We will make these data, we will combine these data, download these data and combine these data and make them available to the services so they can use them. So yes, you're right. And from a technical point of view, I have to be honest, I don't know exactly the problems behind it. But yes, I can also see a future where we will combine these two data sets. I mean, why not? If it makes sense, if it meets the requirements of the services, why not?
Yeah, it's Arvid from Norway. There are some different initiatives on other sources. For instance, also from Eurogeographics, you have for one of these data sets, you have an administrative unit database, the Euro boundary map. So that's a source, that's just complete. So there are different sources, and also the initiative of like a core reference data from OpenELS. That's they're working on the hydrography now, working also on the transport networks for the full Europe. And so I think a closer cooperation with mapping agencies or other authoritative data owners, because if you are trying to make some unauthoritative data, that is also a problem. And that has been the case all the time with the Copernicus in situ work, that you go in different directions, and you are not fair with the initiatives that are already in place. So much more close contact with the Eurogeographics on the topics where they can be active.
Well, I cannot disagree, of course. I can also inform you that I participate in what they call the Copernicus Knowledge Exchange Network, which is part of Eurogeographics. I will also do a presentation at the Eurogeographics Knowledge Exchange Work for Inspire in December. We have made an evaluation of ILS right now to see if it's really fit for purpose when we talk about Copernicus. We have provided a lot of useful information to them, and we are in dialogue with them. But you're right about OpenELS, for example, which would be one of my questions. I mean, and maybe we can talk afterwards, because certainly we are not going to redo what is done already. We are not going to spend taxpayers' money twice for the same purpose. No, I mean, we are not going to do that. So, if somehow OpenELS is the answer to this question, by all means, we will work together.
Okay, so good morning to everybody. Can you hear me well? Yeah? My name is Mar Gonzalez. I work for GMB, who is located in... Is it okay? No? Okay, thank you. Who is located in Madrid, in Spain. And I am the Deputy Coordinator of AfriCultuRes project. I'm going to try to explain briefly in the following 10 minutes what are we going to do with the title that we have in the presentation, using space technologies and geospatial standards to improve food security in Africa. Wow, sounds great, no? So the first question that we need to answer is, what is AfriCultuRes? AfriCultuRes is an A2020 project in the call of Geoss services for the monitoring of agriculture production in Africa. It's led by GMB, and the main challenge that we have is that we have a lot of partners. The half of our partners are coming from African countries. As you can see here in the consortium, it's not very small, the letter, okay. So we have different and multidisciplinary team. We have companies coming from small and medium enterprises, we have academia, we have institutions. So it's a very multidisciplinary team, and the most important thing is that we have a lot of African countries in order to work with. So we are starting. The project started almost 1 year ago, in November 2017, and it has a duration of 4 years. So which are the main goals and objectives that we have? What is AfriCultuRes stands for? Enhancing food security in African agricultural systems with the support of remote sensing. So the main idea that we need to do is to provide a decision support system to support improved decision-making in the field of food security in Africa. So we have 3 main objectives functional that are to improve crop and grassland monitoring and forecasting. This means diminish its objective anaerobic crop area, upcoming threats through risk assessment. We will do that with different predictive models and with different activities of the services that we are going to develop. And in order to get this working, we will do in different stages, 3 main stages. One of these is the validation, the other one will be the pre-operational, and the last one for the operational part that is intended to be at a continental level. So it's important for us to have a very user-friendly platform. We are going to use open source tools, and we are going to develop some of them. And of course, it's important to build capacity and leverage awareness raising. So we have a lot of inputs. We are going to use future climate, the predicted models that I was speaking before, weather, crop models, sensor and services, observation, ground sensing. And it's very important in our activity, the user requirements and risk analysis. We have been starting very early with the user requirements, speaking with the people, speaking with our partners and with the stakeholders in order to see what is the main issue that we have. And as my previous colleague was speaking about, we have detected that we had a lot of different data coming, and some pilots can be covered with some data and other ones with other data. So with all the things that we have an unique output that is the food security decision support system. And our idea is here where Inspire comes to develop interoperable, shareable, reusable, and discoverable geospatial services. Okay? So how to accomplish that? What we have in the left side of the slide, we have the workflow that we provide for the outputs and deliverables that we are going to produce. And one of the most important and basic ones is the data management plan that is at the beginning made, and it will be updated in the following months, each 6 months. And this is very important because here we are going to define, and we are defining it, and we have defined it, the data findability, accessibility, interoperability, and reuse. So the main strategy is focused in 2 points: to register data into Geoss platform and the long-term archiving into Pangea repository. So who does know what is Pangea here? Okay, not a lot of people. So for your information, it is a data publisher for Earth and environment scientific area. It's supported by different portal tools like Geoss. And on the right side, what you can see is all the relationship between Pangea, GeoDAP, etc. And that's why we have selected these kind of things in order to be able to everybody in Africa to interconnect everything. And we have applied the extension-inspired metadata regulation, and we have defined vocabulary, defined it already by Geoss. So where are we right now? I have introduced you before that we have started with the user requirements, and it's very important to emphasize and to stress the co-design and co-development that we have in AfriCultuRes project. We have started with the user exercises, definition of fair batch, of needs by the African partners. We started with our African partners fulfilling some different user exercises in order to detect the first analysis. We are currently developing the user workshops that is led by African partners and with the support from the University of Sheffield. We intend to finish all of them in the following weeks. And we have the users and advisory board with specific people that will work with us in order to follow up the initiatives and the users' needs that will be accomplished during the project. And the iterations are very important, as I told you before. We have 3 different stages: the test, the validation, and demo phases. So, a summary, which are the countries that we are working on? As you can see in the right side in the map of Africa, we have different areas. We have the North Africa, Mediterranean, the Sahel, the East African highlands and Equatorial and Central, and the Southern Africa. We have 8 different pilot countries with different regions. So the diversity of climate, ecosystems, and farming conditions is incredibly huge, okay? So we are supported by Africa Union, NEPAD. We are working, we are very involved in Copernicus and Geoss and Africa. And I'm sorry because this presentation has been very theoretical, not so practical as the two previous ones, but this is the stage where we are. We are just starting, and that's all. So if you have any question now or later in the coffee break, I will happy to answer.
Thank you, Mark. It's just for curiosity. You are talking about integrating future climate data. Are you now considering to use the CDS as a data source?
Sorry. Yes. In fact, what we are going right now is to defining, I didn't explain it, but we are defining the services portfolio that we are going to use. And it's very important, the climate services for us in order to see which will be the best way to work with the fields. So the answer is yes.
Good morning. Thanks for the nice presentation. I was just
Thank
wondering
you.
who is on your advisory board.
Sorry?
Who is on your advisory board right now?
We have people from Africa, from the GeoGlam, and we have people from AfriGeos. If you want, I can say you the perfect name next in the coffee break.
So, good morning, everyone. So, some frequently asked questions about core data and InSpy. Maybe for the newcomers, the first obvious question is, what is core data? Core data is an initiative from UNGGIM Europe. UNGGIM Europe stands for United Nations Initiative on Global Geographic Information Management. And there are activities at global level, but also at regional level, so at European level. And at European level, there is a working group on core data. And the objective is to define what is core data and to encourage member states to produce and supply this core data. As definition, we have defined core data as priority data that should be geospatial, and that should be the most useful to analyze, achieve, or monitor the Sustainable Development Goals, either directly or indirectly. In a first step, we selected 14 core data themes, geographical, mainly from Annex 1. You can see them: geographical name, administrative unit, addresses, cadastral parcel, transport, hydrography, but also in Annex 2, such as elevation, land cover, orthoimagery, and even in Annex 3, statistical units, buildings, governmental services, and area management. Generally, the second question, when people have understood what is core data, is why an initiative on core data? Because in Europe, we already have InSpy. So what will be the added value of core data? Yes, we already have InSpy. InSpy is about harmonization of existing data, generally with a common exchange model. It ensures interoperability at European level. But the content is still heterogeneous. For instance, there is no indication about what is the expected level of detail, most attributes avoidable. So even with a common data model, the result content may be quite heterogeneous and sometimes quite poor. So the idea, or not the image, InSpy can be seen as a big cheese, but with lots of holes. And there are so many holes sometimes that users begin to complain. We have seen some examples. So the idea maybe with core data is to have something smaller but more compact and with real content in it. So core data is about, it's not, InSpy is about delivery, according common rules. Core data is about production. It's about encouraging production of new data or upgrade of existing data. There are common requirements due to the SDG and other user requirements. So it's good rationale to have common minimum content. Core data is not about perfect data. It's about minimum data. It's about defining priorities for this production of upgrade of new data. So, not 2 words, but 4 words. INSPIRE is about commons, is about structure. Core data is about content. Okay, so the third question now, we have core data, we have INSPIRE, but what are the commonalities and what are the differences? What is different, what is common? And I will focus in the I will say in the specification, in the technical recommendation in this next slide. So first, why commonalities? INSPIRE, I will say, is a wonderful starting point for 2 main reasons. The first one is that it provides common vocabulary, common understanding. We know what we are talking about. Maybe we have different opinions about if it should be core or not, but at least we know what we are talking about. And of course, the data models provide candidate core feature types and attributes because it's already a list of defined content, at least for vector data. Why differences? The main reason is about the focus. INSPIRE is about the delivery. So generally, there are rather large data models capturing all potential data. No recommendation about other aspects of data content, about levels of details, geographic coverage, and things like this. And sometimes there are overlaps, duplication between themes. For users, it may be of interest to get several views on the same object. It's not a critique, but it's just due to the fact that it's for delivery. And core data, we are about the production of priority content, so the selection of key feature and attribute, so generally a smaller model, recommendation on level of detail, quality, geographic coverage, and we try also, I will say in a way to apply the INSPIRE principle, capture data only once, so only in one theme. Some illustration, cadastral parcel, so it's the general methodology. In general, we begin to extract what we consider as the priority features and attributes from INSPIRE data models. So just by highlighted what is the most important. For cadastral parcel, it's very simple. What is really needed is a geometry and a cadastral reference. But in some times, it's not very common, but we may also add things to INSPIRE if we think there are important things that are missing. But in general, it's rather just selecting the main feature and attributes from INSPIRE. And we are adding, regarding the content, adding quality recommendation in general as quality. For instance, encourage cadastral parcel forming a partition of territory. Typically, in some countries, whole territories under cadastral parcel, but in some countries, the public domain is not, there is no cadastral parcel. So we are encouraging the cadastration of public domain. It's typically an added value compared to INSPIRE because INSPIRE explicitly excludes the capture of new data. Other example that is about hydrography is to illustrate the capture once principle. We think that in core data, we can have only one feature type, the linear watercourse, that may be able to fill INSPIRE in several ways. For instance, the watercourse of physical waters, but also the watercourse link of hydro network, and even for the navigable watercourse, the inland waterway of, not hydro network, if there is a mistake, sorry, of water transport network. It's the idea that there is no one-to-one relation between production and delivery of INSPIRE theme. Another reason Why we have differences? It's because we have different universe of discourse. InSpy is related to environment or policies having impact on environment, whereas core data is related to sustainable development. So it's environment, but it's also economy and society. So in general, we have a wider scope than InSpy. But I will say maybe not so wide, because policies having impact on environment is already, it's not just environment, it's already wider than environment. An example, for instance, we have a theme that is called basic services that is very close to governmental services in InSpy, but as we aim to sustainable development, we have a wider code list than InSpy. In InSpy, the code list is very restricted to environmental, to risk, whereas for core data, we have, for instance, included some power plants or leisure facilities because we think they contribute to the sustainable development. And generally, the last question is about what about core data implementation? How will it be implemented? The status of core data, we provide only recommendation for content. There is no legal obligation. And the question is, why would governments and data producers decide to produce core data? For instance, we generally here, we apply InSpy because it is mandatory. So core data is not mandatory. Will people apply this core data? The first answer is that core data is already partly available. It's a fictitious illustration, but very likely, depending on themes and on countries, you already have 60, 80%, and maybe sometimes even more than 100% of core data. Core data is minimum data, and most countries have a big part of it. Core data is mainly about enhancing existing data and minimum content. You can already have even more than core data. But nevertheless, there are some gaps to be filled, as shown in one of my previous slides. It's about filling the gaps. It's not about making something completely new, but filling the most disturbing gaps. So, how to fill these gaps, nevertheless? One reason, it may be because the recommendations are relevant. We have, I will say, applied the InSpy methodology by making our documents under review of the general geostatistical community, and we got some positive support. For instance, people saying, yes, the recommendations are useful. We try, they are either implemented or useful to be implemented in future. And in general, data producers are willing to fulfill user requirements, and our data is based on user requirements. The other reason, it's encouraged by users. There is a big interest for the core data initiative by the statistical community and also by the European Commission as priority data. There has been a position paper, and some of our core themes were considered as core data for the European Commission, with the idea maybe to promote also not only the themes themselves, but the detailed recommendation for content. And another point of interest, it's the initiative of Eurogeographic about core reference data. At the moment, I will say this initiative is independent from UNGGIM. The initiative was limited to two themes, transport network and hydrography, in order to fulfill the requirements of the new core inland cover second generation to make the initial segmentation of the backbone. Try to convince EEA to use InSpy data for this segmentation. But in future, there may be next version of this core data, reference data, and we can reasonably hope that more core themes will be included and, according to our recommendation. so it's perfect with the timeline. Thanks for your attention. And if you need more details, there is a website of UNGGIM Europe. You can find the report about selecting core themes and the first recommendation for content.
Thank you, merci. Any question for Dominique?
Yes, Antonio Rozarena from the National Mapping Agency again. Thank you for your presentation. I completely agree, of course, with your presentation, especially because we are working together with the UNGIM Europe. Well, only one remark. I think that you need more time in order to convince to the European Environmental Agency and the Copernicus in order to use this information, because the last week, I insist, they decide to open tender to the industry for all different information. It's a pity. Okay, thank you.
Thank you. Any remark from your side?
Maybe it's not really a remark. I will benefit from this remark to make shameless advertisement, because I am also sharing the InSpike Knowledge Exchange Network, and we are organizing in November, by end of November, a workshop about use of InSpike data, and especially the second day will be devoted to which are the remaining barriers and how can we solve them to promote the use of InSpike data for all users, including EEA and the European Commission.
Thank you. Yes, I'm Mattia Santoro from National Research Council of Italy, and I will present today the experience we had in developing the Geoss platform. So a few words about Geo and Geoss. Geo is a group on Earth observation, is a partnership of more than 100 national governments and more than 100 participating organizations. And it aims to connect essentially the demand for environmental data to the supply of these data from different providers. Geo was established in 2005 for 10 years, and in 2015 the ministers committed in order to continue for additional 10 years with this program. So these are the member states that are part of Geoss and and this is a list of the participating organizations. One of the main tasks of Geo is to implement the Geoss, which is the Global Earth Observation System of Systems. That is a system which is trying to connect the different and very heterogeneous data systems from the different data providers contributing to Geoss, and to connect these systems to the users of Geoss. So this is implemented by the Geoss platform, which was previously known as the Geoss Common Infrastructure. And this is the Geoss environment. So we have the upstream layer, which is composed of the Geoss providers. This is a set of providers who run their own systems and are willing to contribute their data to Geoss. These are all connected through the Geoss platform, which is implementing the so-called midstream layer of the system and is connected to the users, so the downstream layer of this. So the Geoss platform is really in charge of implementing this connection between the different users and different user types to the different providers and providers types. So the Geoss platform is a collaboration between the European Space Agency, the USGS, FDC, the University of Geneva, and Geo, of course, and the National Research Council of Italy. It is co-financed via a grant from DG RTD in the EDGE project, and it is it is developing a user-centric approach based mainly on 3 pillars, which are collaboration, customizations, and reuse. And of course, it is coordinated with international players such as European Commission, ESA, and of course, GEO. So which are the components? Okay, we have on the left side here the data providers. As I said, these are very heterogeneous. They have their own systems and they have their own mandates. So they want to contribute their data to GEO. On the other side, on the right-hand side, we have the users, which in Geoss, let's say, are the societal benefit areas, which were identified and which represent the different user types according to different scientific domains that are willing to utilize these data. So the set of components which implement the Geoss platform and which provide this connection are listed here. There are different components which serve different purposes. For example, the yellow pages allow the registration of a new data provider into the system. Then we have, for example, the Geoss status checker, which is in charge of checking the status of the different services contributing to Geoss. Of course, we have Geoss APIs, we have the discovery and access broker, and the Geoss portal, we will see later in detail. We have widgets that can be used in order to connect to the system. We have APIs, we have views and mirrors. I will detail some of these components later in my presentation. Some numbers about the platform, which is currently brokering, we say, more than 170 data providers, providing discoverability and, when possible, accessibility to more than 400 million datasets, granules, we call them, so the single downloadable file. We have 35 languages. And in terms of users, we have recently run an analysis with the European Commission Joint Research Center in order to understand better which are the users of the platform. We found more than about 15,000 unique IP addresses. And this is the geolocation of these unique IP addresses, which cover almost the entire globe, but mainly Europe and North America. And this is the type of users. So we have governmental users and their distribution on the globe. We have academic, commercial, governmental, hosting, private user, and sometimes we are not able to understand. So we have unknown user types. So as I was saying, in Geoss, one of the main challenges we had to face was heterogeneity. The providers that want to contribute their data to Geoss, as I said, they run their systems, they have their own mandates, so Geo has no force. We cannot oblige people to implement specific formats or specific standards. So how do we face this in Geo? One of the components that is addressing this issue is the Geo Discovery and Access Broker, the GeoDAB. This is a mediation component which is exactly in charge of understanding users' requests and map them to the different languages implemented by the providers. This is the set of standard supported by the GeoDiscovery and Access Broker. They cover the main, almost all OGC standards, ISO standards, and other community-relevant standards. The Geoss portal, the new Geoss portal, which was released in 2016, also addresses this heterogeneity, mainly providing different visualizations according to the different results which it receives from the GeoDAB. So it can allow different filtering types according to the different results. So satellite data have specific filters, earthquake data, they have different filters, and so on. So in support to the different user communities, the platform provides a set of so-called reusable components, which include, of course, the APIs, which are provided. We have essentially three kinds of APIs. One is the web service, which are compliant with the most relevant geospatial standard interfaces. Then we have client-side APIs. These are essentially libraries which developers can use on their application in order to connect to the platform. And then we have server-side REST APIs, or which are targeting users that are developing their applications and that will to connect using this kind of APIs to the system. We have also defined the Geoss views. Since we are providing really a huge amount of possible results, the point here is to subset these results by applying a set of constraints, a set of clauses. So you can define a view by specifying discovery clauses and or access clauses. So you might want only to have results from a specific region or only for some specific keywords, so only from some data providers, or you might want to have only results which are available in a specific format because your application is only able to handle that kind of format. So you can define the view and then you can use the APIs to query the system as if it were, as with normal APIs. So these views are exposed, as I was saying, and they can be defined in two layers. They can be consumer-defined view, so client-side, only users accessing that specific client application will be able to use that view, or they can be provider-side, server-side, so all users connecting to the different applications are able to utilize these views. As for example, we did in the Geoss portal, defining some specific views for different SBAs, societal benefit areas. Another reusable component of the platform are the Geoss widgets. So these are widgets which can be downloaded and can be incorporated into existing client applications in order to connect to the platform. So this is for who already has a running application, doesn't want to change everything. He or she can simply add this widget to the client application. And the Geoss Mirror, which is a Geoss portal customized for specific SBAs or other applications. So you can have a web application which is completely similar to the general purpose Geoss portal and which can be customized with logos and utilizing specific views that you are interested in. And this is it. Thank you.
Thank you, Mattia. I'm Anuja Dongol from Saddle. It looks like a very promising platform, but I was wondering about the metadata. Like we are here talking about the collection of a lot of data, but what about the metadata? Like how would I know the quality of data provided or who is providing? I think I missed it out, or yeah, that's my question. Thank you.
Thank you for your question. Well, in Geoss, we have a task which is the data management principles, which is addressing exactly this issue. It is it defined some principles in order to ensure this quality. As I was saying, of course, in Geoss and in Geo, we don't have, the power to oblige the providers, to comply to these principles. What we can do, of course, is providing them with this information, and on the system side, from our point of view, we can use the metadata quality also for ranking. So you get first what is a better described record, a better described result. And this is also an incentive for the providers in order to enhance their metadata.
Any other question to Mattia? Yeah, it's good to see. I've been working in the context of Geoss for several years until last year, actually.
Geoss, the project.
So it's good to see many developments. I wonder just how is, I've seen many different things now, and even a new, we call it now Geoss platform instead of GCI, which used to be the name for many years.
Exactly.
I wonder what is actually your actual contact with the data providers, those which are owning the different catalogs what is actually the way you do to interact with them?
We have in place a registration process. So they contact the Geoss Secretariat. They fill in this yellow page where they provide not technical information, but let's say high-level information. This is my organization. This is what we do. We would like to contribute to Geoss. The Geossec then contacts the Geoss operations team, and we start interoperability testing. So we contacted the technical counterpart. We start testing. If everything goes smooth, we go ahead and the new system, the new provider becomes available. If there are some tunings to do, we implement them, we provide them with our feedback. I mean, there is communication with them. And this also allows us to establish a channel that we can use also when there are issues. For example, the system or the service is not available and these kind of things.
Hello, good morning. I'm glad to be here. Actually, I remember that when GeoCradle actually started, Jose Miguel was one of the first officers. You were in the kickoff meeting actually in Athens, I remember. Okay, so I don't know, Jose Miguel, if you are following the progress in GeoCradle, but I think this session is a nice opportunity for you as well, maybe to see what has been done. Anyway, I'm glad to speak after Matthias as well, because much of the work that has been done in the GeoCradle project is linked to the work of Matthias. So, what is GeoCradle? GeoCradle is a coordination action. It is funded by the European Commission in the framework of the Horizon 2020 project, and the main goal has been to coordinate and integrate the Earth observation activities, the Earth observation state of the art, in a very diversified environment, which is North Africa, Middle East, and the Balkans. So our goal has been to accelerate and establish strong links with Copernicus and Geo, and it's also to pave the ground and to submit a roadmap for the implementation of Geo and Copernicus in those regions. So the aim is actually to make Geoss and Copernicus useful tools for addressing the needs and priorities of the stakeholder community in those areas, but at the same time to bring these communities and the existing capacities in those areas for the benefit of Geo and Copernicus. And so whatever we did in GeoCradle has been guided by the main principle that we have to provide continuous and sustainable Earth observation information to the stakeholder community. At the same time, we are meaning not only Earth observation data, I mean satellite imagery, but also geospatial information which may be derived from Inspire portals, Geoss portals, and any other national or regional portal that it is using open standard and make available freely open data. So this information, of course, as you know, we all admit that it is useful information for decision makers for in order to address the newly introduced notions of sustainable development goals and also regional priorities and challenges which are considered as common at regional level. So we are a coordination action. We bring together many stakeholders from all these, from the three regions. Actually, we have in our network 25 countries from the three regions. that they are active and providing a lot in the GeoCradle network. Whatever we do is cooperation, awareness raising, capacity building, how to use the Earth observation data, how to use the Earth observation services for the benefit of the local communities, and also we are training on how to create data, how to create open data, how to use open standards, and how to establish interoperability with whatever is available as data hub, data portal, etc. So it has been mentioned by other speakers as well, but this activity as a coordination action is strongly engaged with initiatives, flagship initiatives such as EuroGeoss, AfriGeoss, and to some extent to the Inspire initiative. The thematic priority areas, I mean, we are not dealing with everything. It has been promoted 3 areas that are priorities for the regions, which are adaptation to climate change, improved food security. The previous speaker spoke about the AfriCultuRes project, which is on food security in Africa. There is here, I think, a lot of link to be done with the GeoCradle project, because there is a good stakeholder community already engaged also in the domain of food security. And other thematic areas are access to raw materials and renewable energy resources. There is a lot of solar potential and solar energy potential in those areas, so it's a high priority of exploiting all the available natural resources, and in the most efficient way and user-friendly and environmental-friendly way for the benefit of the communities and the countries. The project is strongly linked to societal benefit areas of geo, disasters, energy, food security, public health, and water management. It is served by the Copernicus core services and data from these core services, atmosphere, land, climate emergency, and addresses specific societal benefit goals, which are zero hunger, affordable energy, climate change, life on land, sustainable cities. This coordination action consists of 4 pillars, actually. The first pillar is, which was run in the early stages of the project, has been to identify the existing capacities, monitoring capabilities, scientific skills, everything that was available in those countries, and to report, to assess them, to see what is the maturity of its stakeholder, of its country, but also the region in relation to the Earth observation, how this can be useful for Copernicus, how this can be useful for the geo implementation. At the same time, we reported on the needs in relation to the 4 thematic priorities, which I mentioned before, and to see what are the gaps in relation to the Earth observation, so that we have to fill in these gaps by exploiting the European Union investments in Earth observation and try to address the priorities in those areas. So we did what we call a maturity table, which is an interesting and open deliverable that can be used by many other projects. I mean, especially if you want to see what is the maturity, what is to be filled in, what is the capacity that you can derive from those areas. The second pillar, important pillar, is the networking, what we call network of stakeholders in GeoCradle. Before starting this project, we knew very little about the existing entities, organizations, and their needs and their capacities, their skills. Today, I can tell you that we have a network of more than 300 stakeholders actively involved in the thematic areas of the GeoCradle. They are across the entire value-added chain, so you may find there universities, value-added companies, data providers, decision makers, governmental organizations. And we have established the networking platform, which is a tool that facilitates the access and the communication to the profiles of stakeholders. The third pillar is the regional data hub. This is work that is strongly linked to the work of that presented before by Mattia on how to derive and how to find out the information which is existing on Geoss portal. The regional data hub has been developed as a gateway to the Geoss portal, so that facilitate of the access of the local actors to the geospatial information. But at the same time, it is a gateway to the national and regional portals already existing that are providing open data, open geospatial data. And the third component of GeoCradle is the development of Earth observation innovative services, which are providing daily and continuously information in relation to food security, climate change, raw materials, and energy. The important here is that to develop these Earth observation services, we have used not only the state-of-the-art of Europeans and the skills of Europeans, but we merged and we complemented it with existing monitoring capabilities, capacities, and skills from scientists and private and public domain that exists in these countries over the three regions. We are a coordination action. We ran in the last 3 years 16 regional workshops in many different countries, in Egypt, Serbia, Albania, Morocco, Algeria, Cyprus, Moldova, Egypt, in many different countries in which we had the opportunity to meet with rather interesting audience, multicultural, multilingual, but at the end it was very interesting because we had the opportunity to meet with all these people, to exchange know-how and to provide the training about exploiting Earth observation, Copernicus satellite data, information on open data standards, and also how to make this useful for their own needs. I will stay very briefly about the regional, the networking platform, because I think it's useful also for you to use it and either to register your organization so as to become your organization visible to those communities there, but at the same time to help yourselves if you want to find the right partner there or the right organization to communicate and to establish some partnership. This is a very easy to use platform. It is accessible, it is free, it is open, it is accessible through the GeoCradle portal, and it is actually a tool that facilitates the inventory of regional capacities, to identify the right profile of stakeholders, to assess the maturity of the stakeholder or the organization you are interested in relation to the Earth observation, and also to identify potential partners, as I already said. It's a simple to use platform. You can submit very simple queries, free text queries, by using keywords which are relating to the geographic location of the partner or the organization you are interested in, or also keywords relating to the profile of the organization. For example, I mean, if you in the entry page of the platform you enter just the keywords Greece and food security, it returns you immediately 14 organizations that have been registered into the platform actively in the food security located in Greece. And of course, you can go and visit one by one and see what they are declaring to do. And if you restrict more your query, and instead of Greece you put the city of Thessaloniki, you restrict even more the returns of the system, and you can find out, I mean, exactly what you need, etc., etc. So I see that the chairman gives me only 1 minute more, so I will try to to be fast. But anyway, I mean, visiting the networking platform GeoCradle, I'm sure you will be able to find by yourself a lot of the capacities and capabilities provided by it. Anyway, the next and I think last topic of my talk today is about the Regional Data Hub. The Regional Data Hub, here you see the whole architecture. The Regional Data Hub is a gateway to the GCI platform, but at the same time a gateway to the existing national and regional portals providing open data to the stakeholders. Okay, it is rather interesting tool, and it was, of course, took a lot to be developed. It was not that easy to develop, but it is easy to use. And it is based on using advanced IT technology. It is the GeoDAB APIs that have been provided by the Geo IT group. And here I would like to thank in person Mattia for his support to our IT group for developing this, for using the GeoDAB API, but also it has used the DCAN software as a front-end interface that provides a very structured way of displaying metadata and data. And the advancements that we have done is that it allows multiple search, remote search of any available portal and data hub. it is providing information on the fly in a rather high-performance way, and it has a lot of clean information. So before it returns to you information, metadata or data, it cleans the data, it cleans from duplicated information or for wrong URLs that are not linking to or are not working anymore to data sets. So, I mean, there are several advancements that have been done so as to facilitate the work of the user and provide the user with rather essential information of geospatial data. And I will just go maybe into the last or no, one or two last before. This is how it looks like. I mean, you can, again, I mean, if you type simply, I mean, a keyword like climate into this data platform, which is also accessible through the GeoCred portal, it gives you some thousands of data sets. It returns you metadata information of data sets existing over GCI platform, but other regional and national portals. There are several filtering mechanisms there so as to take the information you really want, and if you click on this information or on this data set, then you receive a typical DCAN format description of the metadata, providing you description of the information, licensing modes, owners of the data, spatial, temporal information the data is referring to, but also several widgets and previews of the data, if it's geospatial information, the coverage of the data, the geographic coverage of the data set, and several other facilities that are giving you the information you want to have before you download the data on your computer. And the last thing is that as a community and as a coordination action, we are identifying useful portals. We have identifying 42 more portals of geospatial information, which are providing data with open standards, and our work today is to register them into the GCI platform so as to be harvested through the regional data hub at the GCI platform. So I think I could say more, but I understand that I have taken already the time that was given to me. Thank you very much for your kind attendance, and I will be happy to reply to any questions you may have. Thank you.
Thank you.